for Amazon S3. My name is Rob Wilson. I'm a product manager on the Amazon S3 team, and I'm joined today by some of my colleagues.
My name is Mo Farhad. I'm a product manager on the S3 team.
Hi, my name is Romeo Rodani. I'm a solution architect for Thomson Reuters and also a recent data science instructor for Cloud Guru.
Excellent. Thank you, gentlemen. Cool. So let's jump into the session. These gentlemen will be back later on for their portions of the presentation. We've got a great agenda for you all today, highlighted, of course, by a customer speaker who will share their experience on Amazon S3. So we've got a number of other sessions throughout the week. Admittedly, it's pretty late in the game at this point, but these will all be available on video. So if you see anything on the screen that looks interesting, sessions like cost optimization, deep dives on security, deep dives on performance are things where we'll touch on them today, but you might get more details from those other sessions, and it may cover more topics. So these are things to look up later on. And without further ado, we'll start off with an overview. So looking at S3 overall, there are many benefits to the service that attract customers, but the one I want to focus on now is scalability. It's really exciting that you can get started immediately with S3, start to write data, and then scale to petabytes or more without ever having to think about hardware or capacity planning. The storage just scales as you do. And because of those benefits of S3, we have customers from so many different industries that use the cloud. So we have Internet of Things, media assets, could be content origin, data lakes. I'm sure many of you in the audience have different workloads that are represented on the slide, but really the flexibility of Amazon S3 lets you do so much. And once you decide to move data to the cloud, we have 11 different ways to help you do that. And I'll highlight a couple of them now. So we have our Kinesis services for streaming data. They even offer some functionality through Kinesis Data Firehose to take small objects that might be created, maybe small logs, and then aggregate them before writing them to S3. So that's going to give you benefits in terms of managing your storage, but then also lower the request cost because you're batching those objects before you write them to S3. Another one I'll mention is for physical data transport to the cloud. So Snowball, Snowball Edge, and Snowmobile give you the option to actually physically ship your data to AWS. And that's for cases where you might not have the network connectivity to get that data up as quickly as you'd like, and it's easier to ship that. So that's an option for you as well. Now, in this next section, we'll talk about storage classes and all the different options you have when you're looking at Amazon S3. On the left side, kind of thinking about where Amazon S3 has come from, since 2006, we've continued to innovate to make our storage easier to use and also lower cost. So on the left side, you see there's been an over 80% reduction in the price of S3 Standard since we launched in 2006. And on the right side, you see how we've continued to innovate to add more storage offerings over time, most recently with intelligent tiering and Glacier Deep Archive. So that creates a storage portfolio where we've now got 6 storage classes. And when you look across these choices, it's about giving you an option that fits the workload that you're looking for. So starting on the left, we have S3 Standard. It's going to give you millisecond access, 3 or more availability zones. It's kind of a good general purpose storage class because it's going to give you that high availability you need. And then there's no minimum storage duration, no minimum object size. So you've got a lot of flexibility with Standard, and a lot of customers will start by putting their data in Standard. But when you look at the rest of the portfolio, often customers will have data that cools down over time. So maybe for that first week, first month, the data is accessed frequently, and then that access pattern drops off over time. So in the middle of the slide, you see standard infrequent access and one zone infrequent access. Both of them are optimized for infrequently accessed data. There's a lower price point, so about 40% less than the price of standard. And with these storage classes, you have a retrieval fee. So if you're accessing the data about 1 time or less per month, you're typically going to save with those infrequent access storage classes. And then you see 2 choices up on the slides. The difference between the two is that one zone infrequent access stores your data in one availability zone. So it's a slightly lower price point than standard infrequent access, about 20% lower, but it's only in a single availability zone. So you want to think about data that's recreatable, possibly data that's just less valuable, temporary, things like that. So that's a good use case for one zone infrequent access. And then on the left side of the slide, you get over to Glacier and Glacier Deep Archive. So these are for those archive workloads. You're no longer accessing the data in milliseconds. It's going to be for minutes or hours access. With the expedited tier of Glacier, you can get data back in 1 to 5 minutes. So it's as quick as you need it to be for most cases. And then for the bulk of your data, when you have to bring it back, there are low-cost options like bulk retrievals that allow you to retrieve a lot of data at a lower price point. So that might be something you look at when you're retrieving terabytes, maybe even petabytes of data. So really taking advantage of all these storage classes is something that customers ask us about and say, well, which one should I be using for particular workloads? And just think about the characteristics of each when you're deciding on those choices. So we'll talk about some options now for how to move that data. But before that, we'll talk about the one storage class I haven't mentioned yet up on this slide. So intelligent tiering really fits between standard and the infrequent access offerings. And what happens is you put data into intelligent tiering, and then on an object level, we'll move that data between frequent and infrequent access tiers. So what happens is if an object is not accessed for 30 days, it can move to that infrequent tier. As we talked about before, that's about a 40% savings over the price of standard. And then the price of the infrequent tier here is standard infrequent access. So when each object moves to that infrequent tier, you're saving automatically. And it requires no action on your part. You just put objects to this storage class and then get that savings automatically. And I just want to highlight that that's happening at an object level. So whether you're putting 1 million objects in the storage class, 100, 1,000, if there's some objects that are dominating the amount of retrievals and the amount of data that actually is being served, those objects stay in the frequent tier, but the vast majority of your storage could move to that infrequent tier, and that's where you're going to see up to 40% savings when you use the storage class. Now, the thing to think about is there is a monitoring fee with this storage class because we're monitoring that access pattern and tiering the data for you. So the best objects for this storage class are typically about 1 megabyte or larger, because then you're looking at a scenario where that monitoring fee is relatively small relative to the amount of storage. If you're looking at kilobyte-size objects and moving them to this storage class, that monitoring fee may be slightly larger, and you might not achieve as much savings. And since we've launched the storage class a year ago, customers are using it in a major way to save because of how much work it removes from them, especially for complex or changing access patterns. So when there's situations where you just can't predict whether it's the first month or some other time where that data is going to be frequently needed, then intelligent tiering is going to be a good fit for you. Storage class analysis is then a feature that's an alternative to using intelligent tiering, or it might give you the data to say whether intelligent tiering is a good idea or whether it's not a good fit for that data. So storage class analysis is something you turn on for a bucket, a prefix, or all tag data. And after 30, maybe 35 days, so it monitors your data for a period of time, and then it reports on how accessed that data is, how frequently accessed your data is. So the visualization here is just a kind of cut from the console and what you'd see in that view. But from what you can see from this bucket when they ran the analysis is after 90 days is when the data really dropped off to being infrequently accessed. That 1-to-1 ratio I talked about before, that data that's 60 to 90 days old has more access than it does data stored. So probably not a good fit to tier it down to to the infrequent access storage classes. But after 90 days, that data is really cooled off, and now you're going to save when you store in one of those cooler storage classes like standard or one-zone infrequent access. And once you have that data about how is my storage being used, when is the right time to move to infrequent access storage classes, we have lifecycle policies. It's something where you write a simple rule. You can write it for an entire bucket, a prefix, or all tag data. And then it automatically moves the data down to that storage class once the rule is met. So for this customer, after they did their analysis, they found that they could move to standard infrequent access after 30 days. And then after a year, they no longer required that millisecond access. It was offline to their users. You could picture a customer-facing application here where the customer might still have thumbnails that they can browse through. But if they want to get an image back from 2 years ago, maybe there's just a different experience where they click download and then it kind of queues it up for them or sends it to them in an asynchronous way. So that's how customers are using Glacier to deliver a good customer experience, but save a lot on the storage. Another way to think about using lifecycle policies is to tag your data. So then you don't have to think about how do I organize it when I write to the bucket? How do I organize it within different prefixes? Kind of a quasi-folder within your bucket when you think about how to organize it. You can actually just tag data that fits the same pattern. So maybe it's an application that's writing data across that entire bucket. You could say all tagged objects should follow that rule where they move to infrequent access after 30 days, and all other objects, maybe 90 days is the right number. So tags allow you to be very flexible there. And then seeing how easy that is to put into a lifecycle policy, this is the XML way to do it, but you also have an easy experience through the console where you can set up those lifecycle policies and set up whatever rules work for you. The other topic we'll touch upon here is performance. I talked to a gentleman beforehand who really wanted to hear about performance. There's a few best practices on this slide, but I'll tab ahead so you can see the other sessions that are related to this topic throughout the week, and that'll give you a deeper dive. Talk much more about key naming, when it might make more sense to think about your performance ahead of a launch of a new application, for example, what kind of traffic you might expect and how you can design for that. But here I just want to highlight some of the simple best practices. So the SDKs include some performance enhancements just automatically. When you're using the latest version of the SDK and you're staying up to date, you're going to get things like handling timeouts, automatic retries, and then parallelized uploads and downloads just by using the SDK. So for those who are really familiar with S3, using multi-part upload for larger objects is required, but using it for kind of that medium or smaller size object can give you a performance boost by just using kind of the horizontal nature of S3 and using our scale to your advantage. So you can get objects into S3 faster, and then when you're downloading larger objects, using range gets and then putting that object back together on the client side can also add some speed improvements. So these are things the SDK does for you, and you'll just get that performance boost just by using the SDK. And on the bottom, I'll highlight some recommendations we've put out in a white paper recently. It's caching your data for those most frequently accessed objects. That's going to give you lower latency, higher throughput potentially, and that could be through CloudFront, Elasticache, maybe Elemental Media Store, depending on the workload. Other things to consider is scaling horizontally, as I mentioned before, using as many connections as you have on an EC2 instance, on many instances that you have. Don't think of S3 as a serial thing where you have to access it, sequentially in any way. Use the scaled out nature of S3 to get the data as quickly as you need it to a cluster or other workload that you're processing, and get the data you need so then you can get those instances working and efficiently used as quickly as you can. And then transfer acceleration is a great fit when you're moving data across continents. Let's say you have users across the world and all your data lives in the Northern Virginia region. Using transfer acceleration will give them a speed boost when they're uploading the data, and it's something you can activate at the bucket level. You can write into your application to give that performance improvement. In this next section, I want to highlight some of the granular controls we give you for controlling security in your bucket. And we've got some new launches in here as well, so towards the end of this section, we'll talk about how those new launches might give you additional options for controlling access to your data. First of all, security is at the core of everything we do. Buckets and objects are secure by default. They're private to just your account. And then you have these granular controls to then share access with others. Now, on that topic, we launched a feature called Block Public Access last year, because there are a lot of customers who say, the data in my account, it's only used internally within my organization, or I'm the only user of this data, and I want to ensure that no misconfiguration or any change in my policies is going to expose that data and open up that data to the public. So putting Block Public Access on a bucket is just another level of protection, such that your access control list and bucket policy might already be locked down and might already be private, but putting Block Public Access on when you intend to only have that access accessed by other accounts that are explicitly granted, or your own account, is just that extra layer, and it's really a best practice. That's something you can enable at the account or bucket level. In the middle, talking about encryption, we have encryption at the bucket level by default. Then we have the ability to look at the encryption status of all your objects in the inventory report. So we'll walk through an example with that later on. And then the bucket permission checks, both in Trusted Advisor and in the S3 console, are an easy way to look through all your buckets and see in a quick snapshot view, is this bucket public, is it private, and what level of access control is granted at that level. So let's jump into some of the basics on access control for you. The object access control list, bucket access control list, they are ways to grant access to your data, but we strongly recommend using bucket policies and IAM policies. That policy language is consistent across AWS. It's more portable, more flexible. You can do things specifically at the prefix level. You can also grant access to more operations than you can in just the access control list. So we recommend those policies, especially if you're looking to grant access for a new bucket, a new workload. Really think about how you can do that with bucket policies or user policies. When we do think about the object ACLs, that's something where you can only grant read access to an object. Not a lot of flexibility there, and challenging to update when you say, I want to grant access to these 10,000 objects to a particular user, and then when you want to change that in the future, you're going to make 10,000 updates to change that access. There's probably an easier, more efficient way to do that through a policy. The bucket access control list, you can grant access to list the bucket or to write objects to a bucket. But once again, it's to the entire bucket. It's not prefix defined. It doesn't give you that ability to be more granular. So try to think about how you can use policies as much as possible. The feature block public access I mentioned earlier, account and bucket level setting. So when you apply this at the account level, what it does is it applies to all existing buckets, and then it applies to new ones as well. So if you're someone who's an administrator or overseeing an account with many different users, this is the type of setting you might want to put in place at the account level, so then those users have the freedom to continue to create resources, but you ensure that protection's in place for the overall account. And then on the bottom here, importantly, with integration with AWS organizations, you can set a service control policy that says no one can make changes to that block public access policy. So once you've locked down once you've enabled block public access at the account level, you can say no user can make a change to that. And now, once again, it's a control that you're setting at a higher level and enforcing that across your entire account. When we look in detail on block public access, there's actually 4 different settings within it. For a lot of customers, it makes sense to enable all of them. But I'll talk through cases where it might make sense to enable some combination of the 4. So for the first one, those access control lists we talked about earlier, if you say, I'm comfortable with the security I have in place today in the access control policies, I just don't want any new public access to be granted through these, enable that first setting. So if an object is being uploaded with a public access control list, it'll actually be blocked and the put will be denied. So that's what that first setting will do. The second one, let's say you're an administrator of a large bucket, there's millions of objects, and some of them have public ACLs today, public object ACLs. You can then enable that second setting, and even though that access is granted on the object ACL, when somebody does a read to that object, it will be denied when it's a public read because of this setting being in place. So that's the second setting. And then the third one blocks new bucket policies with public access. So once again, everything that's in place today stays, but it blocks new ones. And then that fourth one says if there is public access granted through a bucket policy today, block that. Make sure there's no public access to that bucket, for example. So you've got 4 settings there, gives you the flexibility to pick the one that's right for you, or most customers find that enabling all 4 makes sense. The default encryption we talked about earlier at the bucket level, very simple. You enable it at the bucket level. You're enforcing server-side encryption with S3 keys or server-side encryption with the key management service keys. And then any put to that bucket, you're ensuring encryption's in place. So if somebody specifies a different type of encryption, that will be used because it was specified on the put. But any put that arrived without encryption specified, this default setting is enabled. Those new features I talked about earlier, so these are fresh from Monday and Tuesday of this week. This one was launched on Monday. Access Analyzer for Amazon S3 buckets, something you'll see in the console. It evaluates the access to individual buckets in your account. And then you're going to see which buckets have public access. And you also, importantly, have a section that shows which buckets have cross-account access. So that's net new from what I talked about earlier of what was in the S3 console and Trusted Advisor. This is going to give you a new level of visibility into that cross-account access. So it not only shows you those buckets, it gives you the ability to say, well, I understand this one should be public, and then archive it, mark it that way. Say, I understand this one's fine, let me move it over to this side. You can still view that later on. But then it allows you to focus on the findings that are new or focus on the findings where you need to make some sort of change. And then the other thing it allows you to do is make the change to enable block public access directly from this view. So here's the console view. You see that public access section and the cross-account access section. In the public access one, there's a button right there for block all public access. So if you see a bucket here that you don't expect, you want to put that protection in place right away, you can do it all in this console experience. Easy way to not only identify something, but then remediate it right in one view. Another launch from earlier this week, some of you may have heard it in Andy's keynote on Tuesday. We'll go into a little more detail now about access points and how they can help you and provide more flexibility when you're granting access to an S3 bucket and allow you to enforce things like VPC access. So really good for data lakes, any kind of shared bucket where you might be provisioning access to many different teams. This is going to give you very granular controls to control that access. What's an access point? Well, it's something where you've had a default bucket endpoint, where you've had a bucket hostname where you're accessing a bucket. Everyone goes through the same bucket policy to control access. This is something new where it's an access point that's region and account local. You can give it a name that is then local to your account and region. So for some customers, that flexibility to give the same name to different access points in different regions is going to enable you to write your applications in a simpler way, because you can expect that name to always be there and it'll always be available. So as you're creating access points, create them the same across all regions. Then the only thing that's going to change name-wise between those regions is the actual region name. So that's a benefit for customers. You can put block public access on these access points, and you can enforce that they're VPC only when they're created. So that's another level of control where if you say, I want a bucket to only allow VPC access, you can turn off access through the original bucket endpoint, enforce it only through access points, and then say the only access points people can create are VPC access points. So for a customer who wants to enforce that for a bucket, this gives them all the controls they need. And I want to walk you through some examples on how you can visualize how this works. So this is the previous pattern where all users use the same bucket hostname to access the bucket. And that was then controlled through a bucket policy, for example, because you'd want to control all their different permissions, but it would be in one bucket policy. Now with access points, those individual teams can each have a dedicated access point. And then each of those access points has its own policy associated with it. So the finance team right here, I can put all the details about what I want them to access in the bucket, what rights they should have in that bucket. I'll write them into that access policy for the policy for that access point. And then that's where I go when I need to update that team's permissions, gives me the granular controls. And now it's no longer a bucket policy I'm managing across all those teams, but it's very specific to that set of users. Another thing I mentioned earlier is enforcing VPC access only. So what we did here was we created two access points that were associated with particular VPCs. And then the bucket hostname, we denied access through that path. So the only access is then through access points. And then you can use AWS organizations to enforce that only VPC access points can be created. So a lot of levers there for somebody to be able to enforce the exact behavior they're looking for this particular bucket. In the next section, we'll shift to managing objects at scale. That scalability point I mentioned earlier, where you can grow to petabytes or more, millions, billions of objects in a single bucket, it's good to have these kind of management tools for visibility and then actually making changes across your bucket. So the first one is an S3 inventory report. For those of you who are familiar with the list API, the list API allows you to list 1,000 objects at a time. When your bucket grows to millions and billions in scale, it can be challenging to go through the list API to create that list and just understand overall what's in the bucket. So we launched this feature to be a scheduled report where it's delivered daily or weekly, and then we gather all the metadata and objects for you, create a list, and then store that in your bucket. So it provides some interesting data, things that you would expect like creation date and object size, but at the same time, encryption status, replication status, the tier it's in for intelligent tiering. So if you're trying out intelligent tiering and saying, is this a good fit for this bucket? We're going to give you overall metrics saying, well, maybe 50% of your data is in the frequent tier, 50% of your data is in the infrequent tier. You can get that through metrics. But if you really want to dive in and say which objects are moving to the frequent tier, which objects are in the infrequent tier, this is a great way to do that in the inventory report and looking at that metadata. And when you want to better understand that report, you can use Athena. So Athena is a query service. It will then query that inventory report. It can help you answer questions like this one, which is, show me all the objects that are not encrypted in this bucket. So it's a simple setup here to actually run that query, very simple SQL statement at that point. And then my results in this case, I just wanted to know the bucket key version ID. Because once I have that list of objects that are unencrypted, now I can take action to encrypt them. And we'll walk through how you can do that with batch operations. Because potentially this list is very long. If you have a large bucket and you need to take an action across thousands or millions of objects, it's nice to have a managed solution to do that for you rather than having to do it yourself. So batch operations is designed for exactly that use case. You provide a list of objects to batch operations, and then you can choose from those 5 operations you see in the middle. So that could be something simple like tagging objects or copying objects, but it could also be something really complex and really interesting like running a Lambda function. So a Lambda function, in some other sessions we did this week with the Chalk Talk, we ran AWS Comprehend Medical. So we were looking for protected health information in medical records. And once we detected that, we applied tags to objects to then restrict access. So that's something you can do with the Lambda function, where you can do that step by step on a particular object and actually go through a lot of objects in your bucket and make that kind of change. And when batch operations is running, you can then see how many operations were successful, failed, and then get a completion report at the end. Here's all the objects we acted upon. Were we successful, failed? Is there any comments there? Something like your Lambda function could then return a result string that you could store in that report and use for follow-on processing or just maintaining a record. So here's another view of how that flow works. You can use an inventory report as the input to batch operations, or you could make your own list, and as long as it's a CSV format, that's what you hand off. You have the flexibility of the different operations to perform, and then we're going to give you that visibility along the way. So for large jobs, being able to see the progress that's made along the way and being able to see if that job is running at 100% successful so far is a good input for you to have in the early stages. That example we talked about earlier with trying to encrypt objects in a particular bucket, let's say I enable default encryption. And maybe I turned that on a year ago, but my team has said, well, do we know all the objects are encrypted? How do we ensure all of them are encrypted? Use that inventory report, filter for only the unencrypted objects, and then use batch operations to copy those objects to the same bucket and then enforce encryption when they're written on the copy. So you can do that through the default encryption feature where the written objects are then encrypted, or you could do that by specifying encryption as part of the copy. But now you've overwritten those previously unencrypted objects. Now your whole bucket's encrypted, you've got default encryption in place, and now it's hands-off from your perspective. And because this tool is managed along the way, the only thing we were really doing along the way was writing that SQL statement to filter for the unencrypted objects. And we've got some examples for you, but this is an example of how you can take batch operations and use it to do something that could be across millions or billions of objects, but do it in a very simple way. The last thing I'll emphasize and just recap is what you can do with Lambda and batch operations together. That's going to give you the ability to pull in AWS services to run different types of operations, but then also to write your own custom code and run that on the objects. Other ways customers have looked to use this feature is you can use the base case of here's a list of S3 objects, go ahead and perform this operation. But if you want to send more information to your Lambda function, you can use URL encoded JSON in that manifest, and that's where you can send along parameters. So something like, I want to rename some keys in my bucket. I want to take the existing naming structure and change it slightly. If you can list that out in a manifest and say this is the source and destination key I want to use, then batch operations can use that, input it to your Lambda function, and now you're doing more of a custom copy and actually specifying exactly what those parameters are for each object. So it allows you to do a lot there. And then the other way to think about this, and depending on how you're using Lambda, is I just want to call maybe thousands, millions of Lambda functions, and I want to have a different input for each. You can do that through your manifest and batch operations. So it might be a different string of numbers. It might be some other set of characters that you want to feed into Lambda to have some other processing happen. That's something you can do through the manifest in batch operations as well. And on the bottom, calling services like AWS Recognition. So if you have millions of images in your bucket, you don't know a lot about them today. You don't know much about what images you have, what's in them. Are there celebrities? Are there other things that Recognition can do? You can then call Recognition as part of the Lambda function. You could also do things like copy with the parameters we discussed before, or running your own custom code. So a lot of flexibility when you put these two features together, and we're excited to see you all and see how you do it. So next, we will bring on stage one of our customers. We'll bring Romeo out here. We'll talk about how they're using Amazon S3.
Thanks for that great overview. So how does one of the largest news agencies use S3? Well, before I get into that, let me tell a bit about Reuters and what do we do. So Reuters is one of the largest multimedia news agencies in the world, right? And they are the news source for the news networks you actually watch. So we are a wholesaler, which means that we actually sell raw news content in various different formats to customers such as the BBC, the CNN, the New York Times, or the Washington Post. We have a global footprint of more than 2,500 journalists and hundreds of bureaus globally, where we actually gather news for you in various different formats. Our news gets pretty much anywhere. The global reach can go up to billion views on various different platforms such as cable television, online web portals or websites, mobile applications, or potentially even on radio. Reuters is famous for unbiased, accurate, swift, breaking news coverage, and we were always a frontrunner from the technical perspective as well. Fundamentally, Reuters is an engineering organization. But because of the global reach, as you can imagine, we need to receive and we need to send data to location where, internet might not be necessarily accessible. So not just because of historical reasons, but also because of that technical particular reason as well, we need to have large-scale satellite-based distribution and contribution networks as well. So Reuters has a long living past of being an innovator and a technology company. We serve a wide range of content, starting from videos, pictures, text, and we also have a large archive going back to 1896, consisting, or actually started to consist around 700 of terabytes of content or tape backups. But as we saw the internet becoming more and more accessible, we realized that we need to start figuring out how to use that. As most people, initially we turn to third parties, and we use their help to obviously use that as a storage backend for us, but also as a content distribution network. Long term, that turned out to be, definitely not beneficial. We realized that even serving our breaking news content, which we consider all the content that we, distribute within the last 30 days, and also our archive content, which is basically everything that's older than 30 days, started to become more and more difficult to serve out. We had very little control over our content distribution network. We had very little visibility. Also, it required extensive support from our perspective as well, and the performance was just not consistent at all. And I mentioned we have a lot of bureaus across the globe. You can imagine those are effectively like mini data centers, basically. We have on-premise infrastructure for that, and they are literally like small islands. But how could we help those islands to actually collaborate better? So what is common in these three solutions or three use cases? Well, their solution, and that would be AWS, the cloud, and S3. So before we actually completely migrated over to S3, we actually spent a good few time, and spent a good few, weeks and months to even build POCs before we get the confidence to even start off with it. And one of the POCs and one of the solutions we built, I actually did a presentation about that last year as well. It was called Reuters Lives. So if you're interested in learning more about live streaming and how Reuters does that, feel free to check it out. So once we realized the benefits and also, how you can cut costs using the cloud and more specifically S3, we realized that the best decision would be to actually fully invest into putting all of our content onto S3. But not just the scale that was super useful for Reuters, but also some of the capabilities such as the multi-part upload API. I mean, as you can imagine, because we serve and we acquire and gather very large video files, we also need to upload them efficiently, right? And using the multi-part upload API, we could actually cut down the time on how much it takes to actually upload a large file, potentially going up to like gigabytes even. So it definitely enabled to have faster uploads, faster contribution, and it also helped us to make it easier to distribute our content to our clients. Not to mention to have full access to the AWS ecosystem at that point. So let me show you a quick diagram about one of the, I guess, it's a pretty standard workflow for news agencies in terms of how we actually acquire content or how third parties or our partners contribute content to us as well. In most cases, they either contribute potentially via FTP, or they use our web form, log in with their MFA device, upload their videos, all of that capability is actually containerized, or potentially they would have an RSS website which we actually crawl or, constantly monitor whether they have some new content that we could potentially serve out through our platform. So once we acquire their video content and text that, helping that particular video to be served out, we obviously want to standardize on how we store that metadata as well. So most news actually arrive within like XML format. So obviously we want to turn it into something that's easier to store, such as JSON. And once we have that transformation done by Lambda and we have the video, we just put that onto S3. And after that, it's all basically data-driven, right? And most of it is also serverless, where we can do that. So once we have the content on S3, that kicks off a Lambda function that triggers like a workflow for step function, and we start to do the video processing against the content to make it ready and available to be served out across the globe. But how do we serve it out across the globe? Well, so we didn't just migrate our storage backend, we also migrated our content distribution network, and we moved completely over to using CloudFront. So for us, S3 and CloudFront really goes hand in hand. But it was just so ridiculous how much easier it was to set up, for example, CloudFront compared to like, going to some of these third parties and set up a CDN through them. I literally took a couple of minutes to set up a content distribution network and make your content accessible globally. But it wasn't just the fact that it was super easy to set up. It was also so much more scalable. It was so much more performant as well. The throughput just significantly got better once we moved over to use S3 and CloudFront. So for us, it really goes hand in hand. I guess one thing to point out with CloudFront as well, it's super cheap, but if you do have a consistent workload and you know exactly how much content your customer is going to consume, pay attention to potentially opt into like a reserved capacity option. That can save a lot of money for you. But back to S3. So we have seen a good overview on the storage classes as well. And as I mentioned, we have breaking news and we have archive news. And some of these patterns actually perfectly aligns with the storage classes that AWS offers. So for example, the infrequent storage class and the Glacier storage class saved a ton of money for us because it aligns perfectly with our breaking news coverage. So the second use case I mentioned is that we have a massive archive. As you can imagine, all of that was stored on tapes. It's a content going back to 1896. At that point, it was around 700 terabytes of content. Now it's probably more than a petabyte. But imagine that all being on tapes. So once we had that confidence to build a cloud solution, because we've done that before, we realized one of the main objectives for that solution should be to try to build it all serverless. The second one, as I mentioned, is standardizing or trying to standardize on that metadata. Because if you have a content going back to 1896, you're probably going to run into a good few different standards throughout that time. So as part of our migration and as part of this project, we also had to come up with various different workflows to create this solution within the cloud. One of that was to actually digitize all that content from tapes. At that point where we actually done this project, we didn't have so Snowball wasn't even available. So we actually have direct connections going back to the AWS data centers. We were all uploading all the content up into S3, spun up a lot of spot instances, and did a batch processing against all of them, running for like months. As you can imagine, breaking news is not going to remain breaking news for too long, right? So the volume of news coverage is actually diminishing with time. So we had to also create a workflow to get the new content that should be now part of the archive to be processed and ingested into the archive capability. So that was another workflow we had to create. The third one, the last one, is to try to create a solution which can actually provide an on-demand video processing capability for clients who wants to get our content. But because we don't really want to have all the permutation of our video stored in S3, we wanted to create that in an elastic and on-demand approach. So what I mean by this is, imagine in Europe, for example, they consume videos in 25 frames per second. In US, it's all 2997. Obviously, there are people who like MP4. Some people consume AVC I50, AVC I100. There are a huge permutation of video files and options in terms of how you could store your content. But we don't want to store all of our archive in all of those versions. We want to have the capability that when the client comes to us, we can actually create that particular version for them in real time, if it's possible. So that's what I'm going to quickly demo. I actually got a video of what I'm doing here, but this is the Reuters Connect marketplace where basically you can access the Reuters content. So what I'm actually going to do here is just going to go into our video feeds, order them to basically show you the oldest content that we have, and by that actually to show the video archive that we have, and try to download one of those files in 25 frames, for example. And then I will go through what actually happened in the background. So I chose the Wright brothers' first airplane flight. So that is all stored on S3, and as you could see on demand, I just clicked and it downloaded the file for me. All looks pretty simple, right? I mean, it's news content. So this is what happened in the background. You are the customer on the bottom, and what was actually going on is When I went through that search and I found my content, when I clicked that button to download that file, what happened was I actually made some API calls to the Amazon API gateway that we got set up, which was actually just triggering off a simple Lambda function that started the whole workflow to actually start doing the processing against that particular file, scale up the instances, and actually start to trigger the business logic that we might require in this particular case. Because we have a large data set within Amazon as well, or within S3, we wanted to create an index for that to make it easily searchable. So all the metadata is actually stored within Elasticsearch, and within Elasticsearch, we have the location to all the videos within S3. And when that particular workflow was kicked off, that was actually triggering, to scale up some EC2 instances, potentially additional containers, depending on whether you needed GPUs or not, do the processing against the file, put it back onto S3, and serve it out through CloudFront. And then the client just got the file, basically, and it downloaded onto their workstation or potentially into their capability if they were using it all via APIs. Now, as you can imagine, there might be videos which could be longer than this, maybe like, I don't know, half an hour or 1 hour or a year render or just, like an aggregated video about what was going on in this year. In those cases, you don't really want your client to sit around and wait for that particular process to happen, even if it's real time, because, that's just boring. So that's where we ended up using Amazon Simple Notification Service to actually send an email notification to the client once the actual processing has been finished, so they don't need to wait around. So I mentioned we have a pretty large footprint in terms of bureaus as well. Now imagine a normal day-to-day workflow where you have a camera crew, they go out on the field, they try to capture some videos, and maybe they don't even have internet access, or maybe they do, but it's like really not stable. And then you have another set of people, a journalist, who is going to edit that content that should be brought back either physically, maybe as an SD card, or maybe they could actually publish it back to the bureau that's closest to them. Now, some people need to edit that locally. You need to have like a file storage there, or like a NetApp, or something like a file share. And then after that, you really need to push it back into the headquarters, process it again to change it into various different frame rates, various different formats, and then you make it ready for distribution. Now, the cloud can help to eliminate so many of the steps in this particular process, and that's what we're actually working on now as well, is not only to try to publish all of our content directly into the cloud, but to try to do all the processing closest to that particular event, closest to that particular location as well. Because that will actually enable better collaboration on stories. Like imagine what we could do as well. You have, let's say, 4K or 8K content. You could put all the raw content up onto the cloud, maybe reprocess them to create a proxy of those files, maybe a smaller resolution or a smaller version of that particular file, and let the journalist edit that rather than the raw file. Because, streaming down 8K content onto someone's workstation, that's still not really going to happen, right? I guess depends on the location. But in most cases, you really want to have some low resolution version of the content so people can edit against that, and then maybe still make the change on the raw file itself. Now, this move to the cloud will not just help with the collaboration, but also help with minimizing the technological footprint. Because what we could end up going to or moving to is to potentially just have a laptop for every single journalist, and that's about it. And also, it will enable machine-augmented metadata at source, because there are so many machine learning services that you can now plug in. So what are the list of features that we actually love from S3? Well, I mean, I already pointed out that the storage classes are like just perfect for us. Like we literally are the best example of some of these storage class options. So we do make use of obviously standard for all the breaking news content. If it's getting older, then we move them or transition them into infrequent access. And if it's even something that we don't really want to use, or we know that it's not going to be used in this year, we move it to Glacier or even to Deep Archive or Deep Glacier. And obviously, you also want to have like a copy of your raw content. So Deep Glacier is perfect for that too. And it really makes it easy to use those simple lifecycle rules. I mean, actually, to move this petabyte scale of content to a different storage class, you could just set up a simple transition to do that within literally 2 minutes. Simple bucket policies, again, absolute favorite. Because imagine, like, there might be clients who are also in the cloud, right? And if you actually want to give some of your content to them, or actually give them the capability to potentially use it, what you could do is set up some simple bucket policies to just let that particular account to read that content. But also at the same time, you don't really want to have all your content replicated 4 times, for example, if you have multiple lower environments. You don't really want to have it for dev and QA and PP and production. But you do want to use the actual production data in all environments. So what you could do is actually have a read-only access from your lower environments to your production data set, for example, in our case, to the archive data set, and save the cost. Obviously, request to pay is a multi-part API, really good for us in terms of like the video uploads and in cases where we need to like acquire content from distant locations. Cross-regional application and VPC endpoints to make work with those content securely. The bucket metrics as well. Like, without the bucket metrics, it would be quite tricky to understand what is going on. But with that, we know exactly how much data and how it's growing and how much it's going to cost as well. So why are we so keen about S3? Well, one of the few reasons is that it really enables an event-driven or a data-driven architecture, and you could see as well that most of our capability was serverless, so we could even move even further to move them into Fargate or EKS Fargate or some of those capabilities. And also it really enables us to create larger data lakes and to potentially serve our content out to other people for potentially machine-augmented capabilities or for their own training exercise. That's exactly why the recent announcement around data exchange now has Reuters data being accessible through that marketplace as well. So I mentioned the machine-augmented workflows. So just because we are already in S3, we do enable our capabilities with so much more. Like imagine running through that archive capability or through recognition maybe and just identify faces that we didn't know about or the journalists were not caring about that because that particular person wasn't famous when the video was captured. Or maybe go through comprehend and try to extract some entities from that textual data that we have. Or maybe have automated transcriptions or even potentially multiple different languages for all that massive archive data set, right? And maybe create something custom using SageMaker. And I mentioned that we have a large satellite-based distribution network as well. I mean, sure, I could see a future where S3 will enable us to potentially replace that as well and maybe let AWS handle it for us. And with that, I do hand it over to Mo to talk about S3 access points.
All right.
Thank you.
Thank you, Romeo. All right, let's dive into S3 data protection. So S3 gives you a number of capabilities that help you replicate your data for compliance and protect it from malicious or accidental deletes, or store it in an immutable mode for a retention period of your choice. So let's start with S3 replication. S3 replication is an automatic and asynchronous process that makes exact copies of your objects, including all object metadata, such as the object creation date and time, and version ID. Now, S3 replication launched with cross-region replication in 2015, and since then, customers have used it to replicate trillions of objects and exabytes of data. And customers have asked us to extend S3 replication to help them replicate data within the same AWS region. And a couple of months ago, we did exactly that. And now you could select a replication destination bucket in the same region as the source. So let's dive into how you can configure S3 replication. So first, you select your data set. And S3 replication gives you the flexibility to replicate entire buckets, a set of objects under a given prefix, or even individual objects that you identify with tags of your choice. Now, best practice here to lower cost is to replicate only the data that you need to. And replication based on tags is a particularly powerful tool here. Now, once you've selected your source data set, you select a destination bucket in an AWS region of your choice. And you can select this region based on compliance or data residency requirements, or to place data closer to your users. Now, you can make the replicated data even more secure by using ownership override and cross-account replication so that no single user can delete all copies of your data. Now, depending on your use case for the replica copy, you may choose to keep your replica in the same storage class as the original in a frequent access storage class, or replicate it directly into an infrequent access storage class or an archive storage class such as S3 Glacier. Now, data access patterns often differ for each copy of your object. And so it is a best practice to apply different lifecycle policies for your source and replica objects, so you optimize cost based on their individual access patterns. Now, as soon as you configure your policy, replication will begin as soon as you upload an object to S3 that's covered by this replication policy. And customers are often interested in how long objects take to replicate, which can be influenced by factors such as the number of objects you're replicating or the size of those objects. Now, for critical workloads where you need more predictability and visibility into your replication time, we recently announced S3 Replication Time Control. Replication time control predictably replicates 99.99% of your objects in 15 minutes, with most objects replicating in seconds. Now, replication time control works with all other features of S3 replication and adds a new set of CloudWatch metrics that give you visibility into your replication activity. So these new replication metrics tell you how many objects and bytes are pending replication and the maximum replication time to the destination for every replication policy that you configure with replication time control. You could view these replication metrics in the S3 Management Console or in Amazon CloudWatch and set up alarms that notify you whenever one of the metrics exceeds a threshold of your choice. Now, replication requires versioning, which is another data protection component. You can use versioning to protect all previous versions of objects from unintentional deletes or application errors. And when you enable versioning on an S3 bucket, let's take a look at an example here, and you place an object into it, S3 will automatically assign that object a unique version ID. Now, if you overwrite that object, S3 will keep the previous version and assign a new version ID to the new object that you uploaded. Now, if you delete an object in a version-enabled bucket, S3 will not permanently remove that object. Instead, S3 will insert a delete marker, which becomes the current version of that object. And if S3 receives a GET request for that object that has a delete marker, it will return a 404 not found error in response. Now, you could always restore or delete any version of an object simply by specifying the version ID in your request. Now, to help cut down on the costs of retaining older object versions, you could set up a lifecycle policy to expire these older object versions. We call them non-current versions. And in this example here, we set up a policy, it's fairly simple, that will expire objects after they've been non-current for 7 days. Now, in addition to expiring older object versions, as Rob mentioned, you could also transition them to an infrequent access or an archive storage class. And as a best practice, you should configure your lifecycle policy to remove expired object delete markers and incomplete multi-part uploads. Now, another important S3 data protection feature is object lock. Object lock gives you the flexibility to apply retention settings to individual objects or entire buckets, and gives you 3 retention modes that you could use. First, in compliance mode, a protected object version can't be overwritten or deleted by any user, including the root user in your AWS account. Once you place an object in compliance mode, you cannot change the retention mode or shorten the retention period. Now, in governance mode, you can give some users in your organization permission to do that and delete objects if needed or change the retention settings. And if you don't know how long you need to retain an object in this immutable write once, read many mode, you could use legal hold. And legal hold gives you the same level of protection as the other object lock modes, but does not require an expiration date. Instead, the legal hold will remain in place until you explicitly remove it. Now, with that, let's cover some monitoring tools to help give you insight into your storage on S3. So we talked about the replication metrics earlier. S3 also provides storage metrics that tell you how many bytes and objects are in each storage class in each bucket. The storage metrics are reported once a day and are provided to you and all S3 customers at no additional cost. Now, S3 provides request metrics as well, and you could use those to quickly identify and act on operational issues. These metrics are available at 1-minute intervals and can be filtered by prefix or tag. And this is very useful because it allows you to align your metrics to individual business applications, workflows, or even teams in your organization. And to make them even more powerful, in July, we added support for percentile statistics on request metrics so that you can have more granular visibility into these request patterns. Now, with percentile statistics, you can better understand the distribution of your request patterns, which helps you understand the experience that most of your customers see, and then highlight any outliers or identify any false alarms, saving you the time and effort in chasing those false alarms down. Well, thank you for the time today. There's a lot more available at the AWS training and certification site. Please go to aws.amazon.com/training and follow the storage learning path. I appreciate your time today.